A link to this document is available in the show notes. Here's the schematic of the 1972 game called Pong, done by Atari. Somebody found it to look too complicated, so they colorized it. I think there's about 20 sections on this schematic. Observations about the schematic. There is no code in this design. The schematic is a wall of detail. There's way too much information on the schematic. I count something like 100 threads in this design. The whole game fits on one piece of paper. The sections of the game contain multiple inputs and multiple outputs. All of them are asynchronous. This is hard to say in 1960s programming technology based on Gutenberg typesetting programming languages. This style of thinking and designing is certainly possible. Somebody did it and put it into profitable production. This person didn't need a programming language to think this through. Modern programming languages encourage programmers to design in a way that is different from this design. The idea is to build one enormous lump of code consisting of many tightly coupled clockwork functions. The idea of designing a simple game like this using 100 threads is essentially unthinkable using modern sequential synchronous programming languages. You can do it, but most programmers don't tend to think this way. The original intent for inventing CPUs was to replace chunks of random hardware logic. In 1972, if we had all the money in the world, this game would have contained something like 20 CPUs instead of random logic that's hard to understand. Observing the main failures of this design. The design intent is not obvious. The parts of the design are not well scoped. Again, from a design intent perspective, it's not obvious that the parts are actually synchronized. You have to really understand what's going on to understand what the synchronization is. I go into the synchronization details in more detail, and I provide a YouTube that explains how the synchronization works, in general, in composite video output. The real sweet spot of functional programming is single-threadedness and clockwork-like synchrony. Does functional programming tend towards solving the bigger picture, parallelism and asynchrony? Should we spend more time on making functional programming better and better and better? Or should we look at different ways of doing parallelism and asynchrony?